This video is the next video on trigonometry. In particular, this video is looking at section 4 of the notes, which is angles of elevation, depression, and compass direction. So there are two other points we must note to help us with real life scenarios involving SOHCAHTOA and right angle triangles. And the first one is angle of elevation, and all the angle of elevation is it's the line of vision that you have when you're looking upwards. So for example, if you're looking up at the top of the building, the angle of elevation would be the angle that your eyes make as it goes and looks up towards the top of the building. Angle of depression then, so this is the angle your line of vision makes with the horizontal when you're looking down. So there are two very kind of simple and easy points, but they talk about them a good lot in different types of questions, so it's really important you know, first of all, the difference between angle of elevation and angle of depression, and second of all, exactly what they are. So angle of elevation, it's just the angle your line of vision makes with the horizontal when looking up, and the angle of depression is the angle your line of vision makes with the horizontal when looking down. So it's really, really important to make sure you know the two definitions and what they mean. So the best way to become used to or get familiar with using angles of elevation and angles of depression and where they come into questions is just by doing a few examples of real life questions with trigonometry. So question 4.1 here, it says the sun casts an 8-meter shadow from a tree. The sun is at an angle of 35 degrees. What is the height of the tree? Correct to 1 decimal place. Now in this question they don't specifically mention the angle of elevation or the angle of depression, but what they're basically saying is that the angle of elevation from the ground to the tree is 35 degrees. So with this one, it's very similar to everything we've been doing. What I would advise you to do every time you're doing these questions is draw out a triangle. Even if they have one in the question, it's really easy to make mistakes, so just draw out the triangle. So we have 35 degrees as the angle here. We have the right angle here. This is 8 meters, and we're looking for the height, which I'm going to call x. So what we have here is we have a right angle triangle. We're looking for a side and we have an angle, so it's going to be using SOHCAHTOA. So I'm just going to write down SOHCAHTOA. Now what we have to do next is label the sides. So the side opposite the angle 35 is going to be the opposite. The side opposite the right angle is the hypotenuse, and the last side is the adjacent. The next thing we need to do is highlight the sides that we either have or we're looking for. So first of all, we're looking for x, we need to use the opposite, and then we have the 8 meters, which is the adjacent. So we're looking for the one in SOHCAHTOA that uses O and A. Looking at SOHCAHTOA, we can see that the only one that has O and A is tan. So writing that out, what we have is we have the tan of x, you could say yz, you could say abc, it doesn't really matter, is equal to the opposite over the adjacent. So what we have here is the tan of 35 is equal to opposite, which is x, over the adjacent, which is 8. So then this becomes 8 tan 35 is equal to x. You can pop that into your calculator then to get the value of x, and you're going to get that x is equal to 5.60166. So they want this correct to 1 decimal place, so x is going to be 5.6, and we have units here this time, so it's going to be meters. Question 4.2 says, a wall casts a shadow on the ground. The distance from the top of the wall to the end of the shadow is 13 meters. The angle of elevation of the top of the wall to the end of the shadow is 25 degrees. Find the height of the wall correct to 1 decimal place. So again, what I do here is I draw out the triangle again so that I can make it a little bit easier. So we know that the angle here is 25 degrees. This, of course, is a right angle. This is 13 meters. And what they want us to find is they want us to find the height of the wall, which I might call x. The next thing I need to ask myself, is it a right angle triangle? It definitely is a right angle triangle, so when it is a right angle triangle, I can write down SOHCAHTOA. I then need to label the triangle, so the side that's opposite the angle is the opposite, so that's x here in our case. The angle opposite the right angle is the hypotenuse, and the other side is the adjacent. So then I need to highlight the ones that we need to use. So in this example, we need the opposite, which is x, we need that, and we were given 13 meters, which is the hypotenuse. So then when we go and we're looking at SOHCAHTOA, what we need to do is we need to find one that has O and has H. And the only one that has O and H is sine. So we can write that out. So the sine of x, again you could write yz, sine of ABC, it doesn't really matter. So the sine of x is equal to the opposite over the hypotenuse. So the sine of the angle, and the angle is 25 degrees, that's equal to the opposite, which is x, over the hypotenuse, which is 13. To find x then we can multiply both sides by 13. So 13 sine 25 is equal to x. You can type that into your calculator then. When you type that into your calculator you get an answer of 5.49403. Now it wants it correct to one decimal place, so that would be 5.5 meters tall. And that's the answer for this question. Question 4.3 is a little bit different than the 4.1 and 4.2, as we're not given a diagram, but what it says is from the top of a vertical cliff, the angle of depression of a yacht at sea is found to be 47 degrees. The yacht is 65 meters from the base of the cliff. Calculate the height of the cliff. So I'm going to draw the cliff in here, and then we also have the yacht, which might be here. So from the base of the cliff to the yacht and back down will form the triangle that we need. So we have a right angle triangle. It says the angle of depression of the yacht at sea is found to be 47 degrees. So the angle looking down to the yacht is 47 degrees, and the yacht is 65 meters from the bottom of the cliff. So this here is 65 meters. They want us to figure out the height of the cliff. So the height of the cliff would be here, and we're going to label that x. Then we ask ourselves the question, is it a right angle triangle? And it is. So we can write out SOHCAHTOA. When we have SOHCAHTOA, we can then label the sides. So the side that is opposite 47 degrees is the opposite, so that's here. Side that is opposite the right angle is called the hypotenuse. And then the other side is the adjacent. So what we're looking for is we're looking for x, which is the adjacent. So we need to get the adjacent, and we also have the value for the opposite, which is 65. So we need to go back to SOHCAHTOA and figure out which one has O and which one has A. And the only one that has O and A is tan. So we're going to use tan in this example. So this is going to become the tan of x is equal to the opposite over the adjacent. So in this case it'll be tan of 47 is equal to the opposite, which is 65, over the adjacent, which is x. So then we can multiply both sides by x, we'll get x tan of 47 is equal to 65. Then we can get x by itself by dividing both sides by tan of 47, so it becomes x 65 over the tan of 47. You can type that into your calculator and you're going to get that x is equal to 60.6134. And it wants it correct to the nearest meter, so then x is going to be 61 meters. Another style of question they could ask in trigonometry is they could talk about compass direction, and in terms of whether something is in the north direction, the south direction, the east direction, or the west direction. Or of course sometimes they talk about a northeasterly direction, a northwesterly direction, a southeasterly or a southwesterly direction. So it's really important that you know exactly where north, south, east and west are on a compass and what they mean when they say things like the ship was sailing in a northwesterly direction or a northeasterly direction. So the best way to get used to questions like this is just by doing one. So question 4.4 here hopefully will give you an idea. It says two ships A and B leave a harbour X. A sails in the direction of south 58 degrees east and B sails in the direction south 32 degrees west. A sails a distance of 21 kilometers and B sails a distance of 21 kilometers. How far are the ships apart? Correct to the nearest kilometer. So we have the ship A, and that has sailed 21 kilometers from X. So this here is 21 kilometers. And as well, ship B has also sailed 21 kilometers. They tell us then that they want the distance between B and A, so the distance between the two ships. So this is what we're looking for, so this would be our x in the question. We then need to figure out if this is a right angle triangle. Now they've given us the angle 32 and 58, and if you add them together that will give you 90. So this is a right angle triangle. So when we have a right angle triangle and we're looking for one side of the triangle and we have the other two sides, we can use Pythagoras' theorem. So that c squared is equal to a squared plus b squared. So we can start filling in. So x is the unknown, so it will become x squared is equal to 21 squared plus 21 squared. So what we have here is we'll get x squared is equal to 882. So then x is going to be equal to the square root of 882, and that's going to give you an answer of 29.69848. So they want the correct the nearest kilometre, so that would be 30 kilometres. So the distance between the ships is 30 kilometres, so they're 30 kilometres apart. That's this question completely finished, and that brings this video to an end. I'm hoping that this makes sense. If it doesn't make sense, you can get in contact with me and I'll go through anything that you would like. As well, you need to make sure you refer to your trigonometry cheat sheet the entire time when you're asking these questions to figure out whether you're going to use SOHCAHTOA, if you're going to use Pythagoras' theorem, or both in a question.